Okay, yeah, you guys can get started whenever. Uh, I'll do a quick intro, I guess, for you guys, and then you guys can start if that sounds good. And I'll mute myself right after. Yeah. Okay. Cool. So yeah, thank you guys for coming again. Today it's slightly different from our usual scheduling at 7 p.m. Because our friends here from Hugging Face at LeRobot are in Paris, I think, right now, and it's like 6 or 7 p.m. So we had to adjust the time for them. But yeah, we're super excited to have them. If it's your first time here, we host these reading groups every week related to different robot learning topics. So last week, for example, we had Shiza give a recap on Coral. This week, we're having some amazing friends at Hugging Face talk about the work that they're doing with LeRobot. So yeah, every week's different topics. If you're interested in how in learning more about the topic of robot learning, this is the place to be. Everyone who's super interested in this topic. So without further ado, I'll let Jade and his team present what he has to present today.
Yeah, thank you, Stephen, for hosting us. I'm super excited. So yeah, again, my name is Jade. I'm a robotics engineer here at Hugging Face, and those are my colleagues. So you have Michelle and Divine. So yeah, and we're building LeRobot. So for the people who might not be familiar, so we are this open source robotics library, and our goal is to make robot learning way more accessible for everyone. So yeah, we've amassed, I think we're on the road of 20,000 stars on GitHub and more than 15,000 people on Discord. So we have a super active community there. Feel free to join. We're gonna add a link. Yeah, and also before really beginning, I also want to give a quick reminder. We also released LeRobot v0.4 back in last end of October. And yeah, we have many cool features that you can play around. There's a super nice blog that we wrote. So this is like most of the team that you can see on the picture. And yeah, I think let's maybe begin. So for those who don't know, I think back in 2023, even like a few years ago, robotics was not as open as it is today. And I think the progress that we're seeing today is super exciting. It reminds me, and I think the team, of how was LLM back in 2017. Yeah, and as you may have noticed now, robotics is everywhere. What I mean by everywhere is accessible for students and labs. And I think this is our goal at LeRobot, is to empower anyone who wants to build in the field of robotics, empower students, empower startups, labs, researchers. So like this whole ecosystem. And yeah, and I think we hopefully are leading this trend. We're like, I hope one of the best open source projects, thanks to Hugging Face, that is really funding this whole thing. So yeah, just to give an intro about how we do it. So we have this end-to-end framework where we have from hardware to software to simulation to machine learning. So we can maybe be divided into six boxes if you want. So we host real-world robots that Pipine will talk about. We also host like many ways to teleoperate your robot, collect data sets, and upload your data sets on the Hugging Face Hub. And we have a very not sophisticated but very nice way of handling large data sets and different type of data sets. And then after you host those data sets, you can train many different policies. Policies are, let's say, VLAs. We're going to discuss what is a VLA if you're not familiar. And after that, we also host many simulation environments and benchmarks to test those VLAs. And we just recently launched NVHub, which we will also discuss. So really, if you dive into LeRobot, it will actually teach you everything you need in robotics. So you will have like this full understanding of this full stack. And yeah, I think you will be prepared to build your own robots or to help any companies to have this full understanding of this whole framework. So yeah, we can just maybe get started by robots. This is something Pipine will talk about.
Yeah, so I can talk about a bit more about this. Yeah. Oh, yeah. Yeah. So we have a lot of different robots in LeRobot. We try to be this very open ecosystem where basically anybody that creates a new robot that becomes very popular can just add their own robot and integrate it very easily with one single interface. The robot that you see here, it was a video. I'm not sure if we can play it right now, but maybe. Oh yeah, we can play. Yeah. So what you see here is the robot of Pollen Robotics, a company that just joined Hugging Face this year. And here you see the process of teleoperation via VR, where we collect the demonstrations and also, in the end, autonomous behavior, where the robot has learned something using the framework. So all of this is done and powered by the robot. So both the integration of the VR teleoperation device and also this almost fully humanoid robot of Pollen Robotics. And we have many more robots, also more accessible robots, because the reach is of course a bit more expensive. One of which is this robot, which is now collaborating together autonomously. So this is the VLA doing something to transfer the block, so helping each other a bit. And this is the SO101 robot, which is our most accessible robot platform. It's around $100 for this robot, and we already see this robot throughout our community. I think almost everyone in the community has one. I think over 10,000 robots are out there in the world in our community, and they this makes it very accessible and very easy robot to begin your robotic learning experience with. Here you see the process. So we have one follower robot and one leader robot that via teleoperation can teleoperate the other robot. And it has 6 degrees of freedom, and it's very easy to assemble and to make. So you can either buy it from a kit, from someone else, from one of our partners, or you can 3D print one yourself, easily assemble one within 20 minutes, and directly get started. Which means that you basically have done your first step, which is creating your own robot, and that's also something we encourage to do. So we want people to have some experience with creating their own robots if they want, but also training the ML models and everything in between. And right now we're adding way more and more robots, and we'll talk about this a little bit more towards the end of the presentations. And now I want to invite Michelle to talk a bit more about the next step within LeRobot, which is the data sets.
Hey guys. So in LeRobot, we basically created our own dataset format for robotics datasets. So a big part of the jump that happened in machine learning and deep learning basically was due to having a large corpora of datasets for vision and for text to be able to basically get the most out of these AI techniques or models that are deep learning, basically. So we needed like a large set of datasets that were like a collection of data that would be available online that anybody can kind of use and train their models with. So that part in robotics was lacking a bit. So there was no unified format for robotic datasets. So there are like different formats that were kind of tailored for different tasks and for different aspects of robotics, but there was no unified format that was kind of more geared towards robot learning. So we basically decided to have to create our own dataset format that would be image-based, so it would support visual features, but at the same time you would also need to host you would also need to host the features that are more related to sensors and different like motor aspects. In LeRobot, in the most recent LeRobot format, basically we call it the version 3, so LeRobot v3. It was basically built for the purpose of scale. So the idea is not just to have a nice dataset format that you can use to train your robot learning algorithms. You can also basically start hosting large-scale datasets for robotics in order to allow the explosion of the robot learning field, basically what we're seeing, and the use of foundation models in the robotic space. Our datasets are natively supported on the hub. So basically, if you're working and if you're collecting your own dataset, you can upload it to the Hugging Face hub, and then you can use our tools to basically play around with it. And we have noticed, like, since we have started LeRobot, you can see like the trend in terms of like the growing datasets. All of these datasets are basically not collected by us. This is our community. So you can see we have like now, I think this graph is even a bit outdated. Now we have more than 22K datasets on the hub. There is a nice figure also that also shows the number of unique users that have uploaded these datasets, and I think the number is more than 2.5K. So we have more than 2,500 users that have collected their own robotic dataset and uploaded to the hub. And this is this will be like a gold mine for people that aim at techniques related to deep learning, to basically be able to explore how much you can push these aspects in robotics. And in LeRobot, it's very simple. I mean, basically, you just need to. It's very easy for you to like just create your own data set, upload it to the hub, and then anybody else. I mean, it has a GitHub backend, so you can make it private or public. But if you make it public, basically anybody can use your data set to train their model, and you can use basically data sets that are open sourced by other huge companies and labs to help you train your model. Now I'll give it back to Jake.
Yeah. So I hope you like those different aspects. So as I said, this end-to-end framework, and from data sets to robots, now you can think about like how can we train those data sets, and I think this is naturally will come like the models, so like neural networks. So yeah, I think our goal is to support as many policies as possible. When I say policies, it's just taking observations from different modalities and transforming them into actions that the robots can understand. So I think till 2023 and 2024, we didn't see much, like the concept of VLA was not yet understood. But I think after 2025, we're seeing a big spike of new VLAs. And I think this is thanks to one company in San Francisco, which is called Physical Intelligence. They recently released Pi0. And then after that, I think we just saw the trend. And also thanks to LeRobot, to us, which we are able to provide this whole framework for researchers to test those policies. So just to give you a small summary, between 2022 and 2020, let's say 2024, Pi0 was not released. So the state of VLAs was, we had like a VLM, and then we just directly encode to actions. But after Pi0, which we will discuss just briefly, the architect, I don't know if Stephen discussed this before on previous talks, but yeah, no, like we don't mind talking about it. But yeah, after Pi0, we're seeing many new VLAs, and one of the best VLAs, small VLA actually, which is like very small, which is this one here, as you can see in June 2025, which was released by us, the Hugging Face team. And yeah, after small VLA, we're seeing many new policies such as GROOT by NVIDIA, and we're actually releasing and collaborating on releasing new policies. So we're trying to be like the transformers. Transformers is this house of many models for NLP and vision. For us, we're trying to be like the transformers for robotics, where you can just easily load the models and yeah, post them. So yeah, I think under the hood, what is a VLA? It might be a bit depressing, but currently most VLAs are just a VLM backbone and then an action expert. And after that, you just use flow matching. So you denoise and you compute the loss. Yeah, so the VLM backbone can take different types of modalities, which the most common ones are image embedding, language embedding, and also robot states. Yeah, so and also different type of modalities that we would like to introduce into LeRobot, which we're currently working on, is like audio, and yeah, like segmentation as well, and bounding boxes. This is like a cool research interest that you can go to. But yeah, like after the VLM backbone, you pass those logics to the action expert, and the action expert's gonna get like a noisy action and a noisy state, and it's gonna predict like the correct action. So I don't know if you want to add something to here, but if it's fine, then I can move on.
Yeah, we see that that currently a lot of models are already converging a bit to this architecture of having this specific action expert, which is often a flow matching model or diffusion head. And but there, besides this, I think still there's a lot of very interesting things we can learn from the current LLM research that's being done, and also really rethink also how robots should actually learn in better and more efficient ways, which is something we try to do for a small VLA as well. Yeah.
Yeah, and also we're seeing like a new way of having like sort of paintings, which means how can you have like the policy will output like a chunk of actions, and we're seeing like new types of algorithms that can like do some nice things such as RTC or async inference. But I think this is like maybe on another talk we can talk about it. But yeah, and in LeRobot we aim to support very easily loading VLAs. So this is like the code on how to load. So this is actually easy, because what you do is you just need to have like sort of your data set, and then we provide like full support of how to load the model. And also you can use that model in simulation, which we'll discuss a bit later, simulation frameworks such as Libero and MetaWord. But yeah, like we're seeing this huge spike. We currently support like those policies, but we aim down the line that the community can add new VLAs. And this is a great way for you guys to contribute. Feel free to chat after the talk with me to see maybe you could add like a new VLA. We would be happy to support you and to help you on add this. And it's a huge contribution. So yeah, it will be good for you. Yeah, so after this, we recently launched a new effort. I think back in 2017, OpenAI did like a call to action for the community to add the new gymnasium environments. So gymnasium, it's like you can think about it as trying to model the world, where you have like states, you have actions, and you have observations. So we recently launched EnvHub, which allows you to easily upload simulation environments on the Hugging Face hub, and then you can just easily load them and make them work into LeRobot. Now, if you may ask, like, what is a simulation environment? Well, it's just a set of tasks where it lives in the simulation. So you can simulate using many simulators such as Mujoku, Isaac, or Genesis. Yeah, like we can think about, like, let's say picking a cube. A guy from the community can implement like a new nice task, such as picking cube in let's say Mujoku. He will upload it on the hub, and then using LeRobot, you can just easily load that environment from the hub and then train and evaluate this policy. So this is a bit about like the Twitter post we did. Yeah, so this is like our goal. So as you see, and we aim that the lab students can publish more and more complex environments, such as folding clothes, because it's something complex that we still find it a bit hard to simulate. And then if some guy from the community implements a really big way, then you can imagine folding clothes using LeRobot, which will be really, really impressive. On another direction is we're seeing a trend of new VLA benchmarks, more specifically simulation benchmarks. So those benchmarks are meant to test your VLA on many different aspects. So the current biggest benchmark is Libero, which is like lifelong learning. So it actually tests how policies behave under certain conditions and under certain tasks. So yeah, Libero is currently the best way. I think if I want to make it easy for you to understand it, it's just you have like a Libero data set. Okay, you have certain data sets that is uploaded on the hub. Then the idea is I will train my VLA on this Libero data set. And then after training that VLA, I'm going to evaluate the trained policy on Libero, which is like the simulation benchmark, and see the success rate, how it succeeds, how the robot succeeds in those tasks. And the idea would be that if us as LeRobot, we aim to add many more VLAs down the line, we would have to find a way to evaluate and seeing if those policies are correct. And the current only way to do this is to just evaluate on Libero. So that's also the Twitter post we did on the LeRobot account. And the community pretty liked it because it's currently becoming standard to use Libero inside LeRobot, which we're really fortunate about. And yeah, I would like also to make like a small call to the community. Any one of you also interested in contributing here would be really appreciated. So we currently support two benchmarks, which are Libero and MetaWord. And we have some people from the community and us personally working on adding VLA bench, which is like another type of benchmark that resembles Libero, and RL bench. And yeah, like if any one of you is interested in adding new benchmarks such as RoboCasa, Behavior 1K, or even your own, like if you can build like your own benchmark and showing it to the community, I think yeah, researchers will really value this. And not just research, it's also startups, because startups also want to find like to see how well the policy will behave in the real world. And the only way to do this is to actually check if it actually works before, which is in simulation. So I think yeah, Quine can maybe do a call for the community on what he thinks best way to contribute.
Yeah. So what we see as a last call to action is that our community is really growing very hard, and a lot of people are very interested in robotic learning. I mean, I think it's one of the most interesting fields because it's applied AI real in the real world, and it can do things and explore. And there are a lot of still underexplored research topics and things you can do. So as you see here also in the video, I would encourage everyone to, if you're interested in it, just start, build something, check out the code. Like just start building and start trying to do something. And we have this huge community of people, I think almost 15,000 people in our Discord that are like-minded and are willing to help and all want to share their experience with each other. So I would really say, if you're interested, please join. And it's fairly easy to get started. Right now, it's just a single pip install LeRobot. You can connect to your real robot, but also now thanks to Jade, you can also just use a simulated environment to get started. And also, as you see, we try to keep the API as clean as possible. Hopefully, this is similar to other Hugging Face repos where we just have a single line to initialize your camera, a single line to configure your robot and your teleoperator, and then also to connect and then to teleoperate your robot, which is just 3 lines, just getting your observation from your robot, so the joint positions, and then also getting the next action from your teleoperator, and then sending this action to the robot, and then the observation we can later use to store in the data set. So it's super easy to get started, which hopefully helps in learning this technology.
So we recently also announced like the LeRobot learning course. This is one of LeRobot member, Francisco. I think it went viral because we see that there is a need for students like you, and like not just students, like anyone who wants to learn robots. So yeah, feel free to check the LeRobot learning tutorial. You're just gonna learn like how things work, maybe more into like applied. So yeah, feel free to check the course. If you don't have the link, we can send it to you at the end of the talk. And like we also provide like certificates, which might be also useful. So also there was a big project that was recently done for like around 6 months, which is RL, which is using reinforcement learning. And we recently ported a new RL framework that Michel maybe could talk about now.
Yep. So reinforcement learning, guys, if you are not familiar with it, it's basically the idea of learning from interaction data. So typically you would have a data set. Basically, you would try to learn a model that can map whatever the input of that data set is to the output. So it will try to mimic what the data set looks like by using a model. In reinforcement learning, it's a little bit different. You don't assume that you have a data set. You assume is that you have an agent that can interact with the environment and can get a signal inside the environment to indicate whether it's doing a good job or it's not doing a good job. So it's very good. It's very useful if you have if you want to explore an environment that is unstructured, that you are not really able to get the data out of, or that you're going to face some scenarios that won't be recorded in your dataset. So even if you want to start train a model using a dataset, but then when you deploy your model, you might face some situations that you didn't face in the dataset. So it would be very ideal if you can actually get that data and then learn again, or basically fine-tune what you're doing to improve your performance. So reinforcement learning. So the idea of RL in the real world is still an unexplored topic, because usually we do it in simulations and then we try to deploy what we learned in simulation in the real robot. But in LeRobot, we don't really, I mean, at first, when we started this project, it was before the NHAF, so we didn't really have a lot of support for simulations. So we wanted to explore the idea of what if I can just let my robot interact with the environment or the task that I wanted to do, and how would it be able to basically just learn a policy or a controller in a few steps, basically in as sample efficient way as possible. So because we cannot really afford to sample lots of data, so we had all these kind of challenges to be able to design a system like that. There is a method out there that was published a couple of months ago that was called human in the loop reinforcement learning. And again, the idea was to use techniques from reinforcement learning, but also to keep in mind the main goal, which is to be sample efficient, and to use feedback from the human to be able to learn a policy that can complete a task as quickly as possible. And I don't know if the videos work, but basically we were able to implement a policy that was in 10 minutes, we were able to learn these tasks. So when the robot starts initially, it doesn't really have any idea of what the tasks that it needs to do. However, we give it a reward signal when it completes the task to tell it okay, this what you did right now is a good action and you need to repeat that action. And we have, as you saw, there is a gamepad, so we can also help the robot's action by guiding it sometimes toward the corrective actions, toward the right actions. So it's a bit of a nice interaction between the human and the robot and the environment to be able to learn a policy that will be robust, that could adapt to changes, and that doesn't require a dataset or a pre-trained model beforehand. So this work is still early, so we're trying to use that work to do fine-tune, for example, big models that were trained on large data sets but still lack some performance in some areas. So it's still a very researchy field. There's still a lot of research to do, but if you're interested in reinforcement learning, also feel free to contribute. We have a couple of channels that discuss this point, so just feel free to jump on our Discord and look at what we have right now, basically what we're discussing and we're trying to implement in that field.
Yeah. So yeah, for what's next, I think so we aim to add many more models as again, and robots, and what you want to have a say.
Yeah, so we have a lot of new models, especially now the last couple of months coming out of China, that are really really promising and all open source, which is very nice to see. So we plan on adding a lot of very good and promising VLAs trained on a lot of open data, which is very important. Another thing is, of course, the robots. We try to, as I said earlier, be very open. We'll try to add more robots, such as the familiar robot that is the Unitree, which is very popular. But also different kinds of robots. We're busy with some other companies to add robots that can navigate, so with wheels throughout cities, and just be this very open platform, so you can quickly swap out your policies and robots, because this is a very important and I think also underutilized field, which is there are a lot of policies, but they only work for one specific robot, or a lot of models that only work for one robot. So what we want to do is really give all the tools necessary for people to experiment with training policies for multiple robots as well, and also figuring out on how to do this properly, so we can better share data and better utilize all this data together. And then the third thing is we see a lot of new trends. Of course, just training VLAs with more data, but also some very interesting directions. For example, learning from human videos, which is a motion trends, is an interesting paper, which means that we can directly, for example, maybe use human videos, POV videos from YouTube to learn specific tasks. Recently, I think last week, a huge data set also got released on the hub with over, I think, over 10,000 hours of this kind of video. So it's a very new direction, and a lot of work is now being done towards this. And another thing is, which I think is very interesting, is navigation. You see a lot of VLAs on one side, which can do manipulation and can pick up things and fold clothes perhaps. And then on the other side, you still see navigation being a little bit separate. So you see policies that can just go from A to B and navigate in a room and make a map. But I think something that's very interesting right now is exploring this overlap as well, and seeing how can these VLAs also do more longer tasks. Behavior 1K is a very interesting benchmark to test this on. But really see how we can unify these two directions and see how they can best work together, because this is still something that's very researchy as well. And that's what next.
Yeah, I think as Pipine said, and also support like cross embodiment, which means training different type of robots and making the policy work on different type of robots at the same time, and having like sort of long horizon tasks. So, and also we also maybe have some black holes that we don't really know what's next, like some other points that will come out. The community can help us on that. It would be really great. And this is like we all invite you to contribute. I think now the number of stars doubled, I think, with the last 3 months, which shows that, you know, we're going towards this unified framework of robotics. We're still trying to maintain the library as we scale, but we're still in alpha, which means that we are adding as much features as we can, while trying to maintain the library. So sorry if we have some breaking changes, but I think it is all for the good of LeRobot and not to hurt it. Yeah, and you can also open issues, open pull requests, share, follow us on Twitter. We are LeRobot HF account, and we're happy to repost, retweet your like the things that you're gonna build with LeRobot, with robotics in general. And yeah, like this is we're a team of around 8 people. We're a small team, but we're growing, and yeah, we're just trying to solve this part of open source robotics. And if you have any questions, feel free to ask. I think now it's a good timing to ask questions about us, about our work, about robotics. And also those are like the link to Hugging Face and to the LeRobot Discord. So yeah, I think this is like our main talk. There's many things we could have talked about, but for the sake of the time, we chose like the most important stuff. So yeah, guys, just feel free to ask. Yeah.
Cool. Let's give them a round of applause for the awesome presentation. Yeah, I will. I'll take the questions. It might be hard for you guys to hear them, so I will be here, standing here. So if you have any questions, say it, and I'll just repeat it here so they can hear it.
Yeah.
Perfect.
Eddie.
What is their view on ROS 2 and why they strategically not really try to touch that side of the community?
Okay, so we have a question from a member, which is, what is your guys' view on ROS 2? And
What is their, why have they strategically not decided to?
and why have you guys decided not to use ROS 2 in the LeRobot ecosystem?
Yeah, that's a good question. Yeah, so what is our view? I think it's a very, it's a very nice open source library. It's being used, of course, a lot of a little bit more traditional stack of robotics. I think it's a very good addition as well, and it's something, of course, we build upon. We plan on actually integrating with ROS 2 in some kind of way, because I think the ROS ecosystem is also very important, and a lot of very good robotics people are using ROS, of course. Up until now, we haven't, because first of all, our library is still quite young, a little bit I think 1.5 years old now. And committing to integrating worlds is also committing a bit to this fixed structure, which can be hindering when we develop our own library. But at this point, as we're also trying to integrate more robots, it's really something that's in our priority list. So hopefully I answered your question that way.
Yes.
I have a question. Is it also planned to integrate like simulation to real or real to simulation inside the LeRobot library, or?
Can you guys hear that question? Okay.
Yeah, I mean, I think we have many different roadmaps, but I think the way we're going to converge is for simulation, especially, is people can upload like a sim to real tasks. Let's say picking cube. The idea would be you to upload it on the hub using any simulator you want. Although we can recommend you some simulators that can support like ray tracing and in a batched way. But yeah, the idea would be you uploading it on the hub, and then you can just like load these tasks and train it in LeRobot and see this sim to real part. We also have, I think, a tutorial on sim to real, which was done by ManiSkill, which shows that you can also support like a digital ENV. This is something we might work on, which is actually training using RL. You actually train like your robot, but you remove the background and you put like a digital ENV, and it works. So this will be like our first step towards solving sim to real, which is like adding this sort of digital ENV, but it's still on the roadmap.
I have a question for you guys. So you supported a lot of these like foundation models like Pi0. You also have like VTBet, the Fusion Policy, ACT. So I'm curious to hear you guys' experiences trying out all of these different policies or these different models. Which one works best for the task? And I assume most, and also the different tasks that you guys try, is it mostly pick and place, or have you tried more complex tasks? Just curious to hear your experience with all these different models.
Yeah. So I think I can talk from the simulation side what we tried, and then maybe I can talk about the real world. So from the simulation tasks, we have like the Libero benchmark, which contains around 130 tasks, which tests the robot on not pick and cube. So it tests it on like on object, on spatial detection. So so for Libero, we actually tried like different ways to do it, and also we evaluated it on MetaWord, which is also another simulator. So yeah, the only way to test it in simulation would be to test those different type of tasks, and that can support as well lifelong learning. So from the simulation tasks, no, we are actually testing it from many different tasks, and I'm happy to give more details about the type of tasks that the Libero supports. So for instance, you can say like pick a can and put it on top of the table. The robot can do this. For instance, pick the red mug and place it on top of the blue mug, which is another type of tasks. Yeah. So from the simulation side, we have many different tasks. Actually, more than 300 tasks. And from the real world side, I think.
So from the real world side of things, we evaluated. I mean, we always evaluate new policies that we port. We have evaluated some policies on some more difficult tasks, such as folding. We noticed that still, I think, and it's also the general feeling I get from the people I speak to in the community, is that the Pi0 and Pi05 are still very good. But to start out with simple training, ACT is also still surprises me often with just the efficiency of which it can learn something. One thing, however, is that still in robotics, it is super hard to evaluate your VLA. So also when we edit, we have to sometimes just trust the authors of the paper on their results, because real world evaluation in robotics is still very hard. We don't have just one unified way of doing it. There are a lot of people now, especially I feel like the last couple of months, very excited about real world robot evaluation. And there are a couple good initiatives as well that you can check out. Which basically all test these VLAs on a fixed setup and on like real world robotics tasks. And this is hopefully something that can help on giving us more insights on which exactly is now the best VLA the coming months.
Yeah, at the end there.
They mentioned about creating like a policy that could be used across different robots. I was wondering if they could talk more on that. How would it be possible?
So for different type of robots, you need to have a policy that has certain maximum action dimension. So let's say you have the Panda, the SO, and the Franca. Each one of them, let's say it's 7, 8, and then 6. And let's say you have like the G1 was like 20 degree of freedom. So your maximum action dimension would be 20. But then once you actually training, you will pad the actions. This is like the current method. Now, of course, it can change, but this is how it works. So how it works is if you have like an action data set that is for the Franca and the maximum action dimension is 20, you just pad the action with zeros or like some different ways of doing padding. And then, yeah, you just like once you want to generate the action, it's going to generate maximum action dimension of 20. But then if it's a Franca, it's just going to like cut and trim to like your action space. And another thing we're exploring, a new policy we're currently porting, which supports like domain ID. It creates like sort of learnable embeddings. Let's say you have 6 different robots and each one of them has like 2 different type of cameras. So that means you have the domain ID is 12. So you have like those learning weights, learnable embeddings of 12. And then, yeah, you can just specify this domain ID that you want, depending on the data set you use. And the policy will learn, this type of embedding depending on the robot type. So it's still an open research field, but I think, yeah, those 2 ways are the ones I personally saw. I don't know if the team has something else, but this is like how we see it.
Yeah, good answer.
Yeah.
Does small VLA still use the same action embeddings as Open VLA? Because when I was reading the Open VLA paper, I found it a bit strange.
So I think the difference, I think it's big. I think Open VLA, they directly match the VLM backbone output to the action decoder, whereas small VLA has this action expert denoising. So that's how I remember. Yeah. Yeah, so this is the difference. Small VLA, I may be wrong, but this is what I remember from Open VLA, because I don't think we added Open VLA. We don't plan to add it. Yeah, so I think Open VLA just had a VLM and an action decoder, whereas small VLA contains like this action expert, which like have a flow matching loss.
From what I remember, the Open VLA it outputs like discretized action tokens, whereas small VLA and Pi, they have continuous.
Is it like fusion at the end?
Yeah, that's correct. So back to the Open VLA is of course one of the VLAs that went before Pi 0. And what you saw also with RT1 and RT2 was that it was just an autoregressive transformer that directly outputted the actions or the joints as text, basically. And now, yeah, we see this emergent trend, and where you have an action expert, which is often a flow matching transformer or diffusion transformer, because we don't have to discretize the actions. Yes.
Yeah, at the end there.
Can you inference VLAs from remote TPUs in LeRobot?
Sorry?
Can you do remote inference with TPUs, I guess? Like do ASIC inference with TPU?
Maybe. I mean, we added accelerate recently.
Yeah, we added accelerate, but yeah, maybe.
We haven't tried. We haven't tried. Yeah.
We added Intel support as well, but not yet. No, it's a maybe. Feel free to open a PR or like document it. You can have a look. But if you have a TPU, right now.
If people are interested in contributing, because you guys are also working full time on this, is there any way to know sort of like what are the features you guys are working on? If, like the feature we want to work on and like you guys aren't already working on it?
So I think how we can start is if you just buy robots that are compatible, with the LeRobot, you can just collect dataset and upload it on the hub. This is just the easiest way. It's just like adding more dataset. The second way is, as we said, adding more VLAs. So as you see, there are 3 dots because we're planning to add more VLAs. But of course, it would need the help of the community to open those PRs. But yeah, like you need to be very careful when adding a VLA. You have 2 ways, either to evaluate, on Libero and see the success rate, while also matching the original author action logits. But yeah, like this is another way of contributing. And also another way is to create simulation environments and uploading them on the hub. You can see a detailed guide on the Twitter thread. And also adding, new benchmark. This is something we've said. Yeah, and also you feel free to check our Discord. You'll find many more things, such as RL, for instance.
Cool.
So let me put this slide. Yeah.
Any last questions? Yeah.
Do they have any advice when you're testing out one of your VLAs that to kind of protect the arm from imaging, like the servos? Sometimes, like I've had situations where it kind of like crashes into the table a little bit hard. Is there any kind of recommendation to
Oh, they do have safety protection. I can actually answer that. Or, well, maybe you guys answer, but I think you have like a for example, end effector pose. You can limit sort of like where it is and the max EE deltas. I remember using these safety features in the post processing.
Yeah,
did you
yeah.
get the question?
Exactly. Yeah, we have this max relative action that you can set for every robot, which is the maximal step it can take over one time step. You can also add maximum. You can actually, for the VTEX, for the small motors, add the maximum torque. We haven't have too much documentation about this. That's true, but yeah, there are a lot of different options. So it sometimes feels a bit like, yeah, what is the one that takes the less time for people is the less annoying. But yeah, or just using the IK and setting some kind of boundary.
Okay, cool. Let's give them a round of applause again. Yeah, thank you guys for taking the time, and really appreciate, thanks to the audience for coming out, and a great turnout today. Yeah, is there any final words? Else we can wrap it up for today, and we'll see you next week.
Yeah, thank you very much, and yeah, let's go. We love Waterloo, so yeah. And feel free to reach out if you have any other questions, way to contribute. Just let us know. We would be happy to help.
Yeah, so what's the best way to contact you? On Twitter or somewhere else?
Yeah, on Twitter. On
And
Twitter
join
would be
Discord.
best. And also the Discord server. Do you have the link of the Discord? I can send it. Oh, if you have it, that's cool.
Do you guys
So,
also
yeah.
have a hackathon coming up, LeRobot hackathon?
Thank you. So we will leave then.